Welcome to this explainer. Today, we're diving into a literal game changer of a workflow to keep your engineering and QA teams moving when systems, well, inevitably break. We're zeroing in on a genuinely crucial tool for IT support, Postman mock servers. We're going to look at exactly how you can rip backend dependencies right out of the critical path and simulate API behavior on demand. Let's get into it. Picture this highly relatable, high-stakes scenario. You're an IT support engineer. It's late in the sprint, and out of nowhere, your payment API completely goes down in staging. Right at that exact moment, your front-end team desperately needs to test the checkout flow. Suddenly, development comes to a screeching halt. Everyone's effectively blocked, basically just sitting on their hands waiting for the backend to come back to life. So what do you actually do? Well, instead of just twiddling your thumbs and waiting hours for a backend fix, you can step in and save the day. You can instantly swap out that broken, unpredictable real API for a stable, fully controlled mock API. By doing this, you're giving the front-end team a rock-solid surface to test against, instantly unblocking their entire workflow.
To pull this off, we need to know exactly what we're building. A mock server is essentially a virtual stand-in for your backend, hosted entirely by Postman. When a request hits it, it interprets it, and rather than routing it to a real database, it spits back the exact data responses you dictate. These are responses you've already saved as examples right in your Postman collection. So your front-end testing chugs along seamlessly, totally oblivious to the fact that the real backend is actually offline.
Now, the absolutely crucial point here is the number 0. Why? Because the most powerful part of this whole workflow is that it requires literally 0 backend code. You don't need to spin up a Node or Python server. You don't have to configure any routing or mess with databases. You can set this entire thing up on a totally free Postman account in just a few minutes. So let's look at how we actually do it.
Here's the secret sauce to pulling this off fast. We zoom right into the Postman desktop app. Let's say you've got a collection with your checkout request in it. Step 1, simply open that collection. Next, send a real request to the API. If staging is down, maybe bounce it against production, or just grab a known good payload you have lying around. Finally, down in the response pane, click Save Response as Example. That one single click, that's the entire foundation of your mock.
When you add that example, you're going to want to be meticulous. Name it something crystal clear, like default 200 OK or successful checkout. Then, go ahead and edit the JSON payload body to simulate exactly what a successful transaction looks like for the front end. Once you hit save, that example is permanently attached to the request inside your Postman collection, ready to be served up on demand.
Now let's take this from static to dynamic, because you definitely don't want your front-end testing the exact same hard-coded transaction ID over and over again. To make it perfectly realistic, use Postman's dynamic variables. These are powered by the Faker library, which is this awesome built-in tool for generating dummy data. Just type double curly braces and use tags like random UUID or random int. Postman will automatically generate a unique, random transaction ID every single time the mock endpoint gets hit.
Alright, so with your response example saved and dynamic variables injected, it's time to actually bring the server to life. Simply hover over your collection name on the left sidebar, click the 3 dots icon to open up more actions, and select Mock Collection. This launches the publishing flow, officially transforming your static collection into a live, reachable server.
In the setup panel that pops up, give your mock server a highly recognizable name, something like Staging Checkout Mock. If you're using any environment variables in your examples, make sure to attach that specific environment here so everything resolves correctly. Finally, choose your visibility. Setting it to public is highly recommended for cross-team collaboration since it lets your QA teams hit the URL without jumping through authentication hoops, but you can always choose private to lock it down securely behind a Postman API key.
And the moment you click Create Mock Server, the magic happens. Postman instantly generates a unique URL featuring a specific UUID that routes directly back to your new mock server. This URL right here, it now officially stands in for your real backend. It's live, it's listening, and it is ready to serve up those exact examples you just defined.
So how does this actually unblock your team in practice? You literally just take this newly generated mock URL, go into your front-end application's environment file, and swap out that broken staging base URL. Just paste the mock URL right in. Now when the front-end app tries to process a checkout, it hits the mock instead. Boom, the checkout flow is instantly unblocked. To verify it yourself, you can paste that mock URL straight into your browser or fire off a request from a fresh Postman tab and watch the exact simulated data come back instantly.
But hey, testing the happy path is really only half the battle, right? You can take this way further by saving multiple examples to the exact same request.
You can save an example that simulates a successful transaction with a 200 OK, another that mimics an invalid card with a 400 bad request, and even a 500 server error to represent a network timeout. This empowers your QA team to thoroughly test how the front end handles all of those tricky edge cases, all while the actual real backend is still completely offline.
Now, you might be thinking, wait, how does the mock server know which example to return if I've saved multiple? Well, Postman's matching algorithm generally handles this automatically based on the URL path and HTTP method. But you can absolutely force specific edge cases. From your front-end or testing client, just add a custom header called x-mock-response-code and set it to 500. This intentionally triggers that exact 500 error example you saved, allowing you to perfectly test your app's error handling and circuit breakers on demand. Okay, but what happens if things aren't working? What if the front-end app is sending a request to the mock, but it's just not getting the right response back? That is exactly where you dive into the mock server call log. This is a brilliant diagnostic ledger right inside Postman that displays a complete, detailed list of every call made to your mock URL. You can inspect the exact headers and body payloads the front end is actually sending. It's an incredible visibility tool for support engineers to see precisely what went wrong without having to guess. Honestly, this entire workflow brilliantly illustrates the old philosophy of faking it till you make it. By virtualizing the API, you are completely removing the backend from the critical path. Your backend engineers can take the time they actually need to fix the staging environment, while your QA and front-end teams literally never have to stop working. Parallel development suddenly becomes reality, not just some buzzword.
So, the next time your APIs go down in staging and everyone starts panicking, remember that you have the exact tools to be the hero. You can spin up a mock server, capture realistic responses, save the day, and keep everyone building. If you can simulate any backend scenario in minutes with absolutely zero code, what blocked workflow will you unblock today? Thanks for joining me for this explainer, and I hope this helps you and your team build faster and smarter.